Welcome to a special Code Report YouTube video. In this video, I'm going to be doing something that I haven't done before, which is sharing the last 30 minutes of the screen share of the most recent ArrayCast podcast recording, which is going to be, if you're watching this immediately when this gets released, a few hours from now, but if you're watching it anytime after that, that podcast episode will be out and linked in the description down below. In this podcast episode, we're discussing what makes a programming language, specifically an array programming language. And towards the end of the episode, I ended up screen sharing Microsoft Paint and creating a Venn diagram that breaks down sort of what goes into the array language category, what goes into the Iversonian language category, and what goes into the combinator language category. I then later on went on to polish up this diagram and tweet it out again. So this is kind of the final product. But I'll just leave it at that for now. If you're interested, feel free to listen to the next 30 minutes, and I'll talk about the podcast and also a talk that I'll be giving at the end of this YouTube video. So hopefully
we can see it. Yes,
everyone can see now. All right, this is no longer.
Not sure how we're going to be able to
draw it up.
Yeah,
well, remember to save this image.
It's an ellipse.
Yeah.
It's not a circle.
Second
it's an
ellipse.
ellipse.
Seeing a circle and a circle. Well, it's not a circle, is it? No. Okay.
All right. So now we've got inscribed circle inside another one. And so I'm going to if this is going to get posted, let's do it correctly. So Iversonian.
Starting with the spelling.
The outer circle is Iversonian.
The inner
maybe
circle
it's the area outside
is
I don't know.
array. And now that I think about it, we really should have put for symmetry languages, there's going to be a little bit of a gap here. And I would say, and this is where, maybe I need to think a little bit harder. How do where's my paintbrush? I guess I can still type. Why not just do this? So APL.
Hold on. So the title here refers to the circle that's inside them?
Correct. Yes.
Okay.
I guess maybe I should have done a little color coding.
That's fine.
J. So these are all Iversonian
but they're not array languages.
You might have everything inside out.
Yeah. Surely you would consider these array languages. No?
Yeah.
I mean, PQN's fundamental data type is not an array, but whatever. Let it slide.
Let's do this again. Iversonian languages is the inner circle.
Right.
That's what I thought.
We're in the inner circle.
Yeah.
Okay.
I think that's what I said at first, but then somehow I confused myself.
Huh.
And then array languages is the outer circle, and inside is APL.
Inside
See, his whole problem is
Iversonian
he's
languages,
putting these
Connor
in one
is
at
now
a time.
putting.
We discussed this.
Can you not type them all at once as an array?
No.
No?
And then definitely on the outside is NumPy.
Yeah.
Julia.
Fortran?
R. Jury's out on Fortran because I haven't looked into that one enough. And so then the question becomes, is Futhark? I would put Futhark outside.
Yeah, Futhark is really interesting to talk about because
and I would also put single assignment C. And the reason, and so this brings me to my second eureka moment. So the first eureka moment is that there's this delineation between Iversonian languages and array languages. And I think the things inside Iversonian languages that differentiate them from array languages are the school of thought and the way it makes you think that Bob is referring to. I don't think in my head, this makes you ineligible to qualify for being an array language. But I do think it's essential to what sort of Ken Iverson preached with his languages. And I also think combinators are a massive part, and that's the thing is, so APL, dialog APL ended up, but, and so actually maybe there's actually a different circle here.
So another question is, where would you put Neil? Because I think that's an interesting, in between thing.
Really? Why? What is it about Neil that makes it this whole point of Neil, sure, but the whole point of Neil, okay, it's not Iversonian, maybe that's what you're going to say. It's definitely an array language, right?
Yeah,
the whole point of it is to be the array language.
Is it?
It's taking that array theory and making it into a programming language.
Okay, you can say Trenchard Moore's array theory is the core of Neal, which is also basically the same theory that went into APL2, so that's now seen in all these APLs.
Yeah.
We're all sitting here watching Connor create this image. It's quite fascinating.
I take back what I just said.
Hold on, this is not right, because you certainly okay. So now let's try to describe this a little bit for the listener, so it doesn't become a complete waste of time for them.
I was just gonna fill up time by talking about Futhark.
So okay, so now we'll get
to Futhark.
What Connor has drawn now is an outer group, a giant one called array languages, where he's put Futhark and single assignment C outside of that. Things like NumPy, Julia are inside. I suppose also MATLAB and Mathematica and so on would be in there. Inside that, we've got Aversonian languages, APL, J, BQN, K, I suppose, APL 360. Now, Connor has added an overlap with the Aversonian languages that he's called combinator languages, but it's the way he's drawn it now is it's entirely inside array languages.
Oh, yeah, I see where you're going with this.
That can't be right.
You're correct.
Right?
You're correct, yeah.
Okay, yeah.
I see
it's not inside Aversonian languages, but it does.
It has to overlap, but go all the way to the outside. Yeah. Maybe Microsoft Paint is not the right tool for this.
Blasphemy.
Come on. Yeah, I will not entertain that.
Real programmers use.
You know what I'm.
Presenters use Microsoft Paint.
What's occurred to me is what we're going to do at this point, or earlier on, because I think I'm really going to do this. At the point at which Connor started sharing the screen, I'm going to make a video of it. Because I can just take the shared screen and make a video of that. And people can actually listen to this as we're watching it. Because it really is quite an exhibition of...
Am I get the slash the right way?
No, backslash.
Backslash?
Yeah, that's very important. Also, APL should be in italics.
That's all right. I don't have. That's the problem with Paint is I have a single stack of backspace undo, and so I have to go back 17 steps to fix this combinator languages. Admittedly, I should have done this in PowerPoint. Now that
are there any combinator languages that are array languages that are not Aversonian?
I don't think so. So yeah, there's maybe even a nicer one of these. But for we're good with this now. And I might put,
where does Cozy fit in here?
I don't know enough about Cozy. I might put Haskell down here. And so that's actually the ones that we haven't listed yet. So Q.
Q and K.
I don't know enough about Q, but I don't think they have a rich support for combinators. Like, do they have?
Neither does K.
Neither does K. So
it has it has its own train thing, which is you can parenthesize a sequence of functions of nouns and verbs, I guess is the K term. And when you apply that, it applies as though there were no parentheses, basically. So it has one compositional form, I guess is how you say that. And you can also you can do partial application, which has a lot of uses, but neither of these are really.
Yeah, I mean,
hold on. So hold on. So here about combinator languages, and you're saying having a rich set. So dialog APL is moving as we speak, right?
Correct. So this APL here without the prefix of anything, I refer to as dialog, which is why the APL 360 doesn't qualify as a combinator language. And there would be then many APLs that don't have that rich set that would be in the Iversonian languages, but outside the combinator languages.
So I'd like two exhibits here. One is in K, it is fairly easy because K has functions as first-class citizens to write your own combinators. People generally don't, but there's nothing preventing you from. Another exhibit would be APL2, which does have operators, user-defined operators. It doesn't have very many built-in ones, but it's very simple in APL2 to define your own combinators so that you have all these combinators that you want. Whereas in APL 360, and even APL Plus, I think, you cannot define your own operators, and therefore you cannot create combinators. So there's when I'm trying to make distinction between the ability to make combinators and comes with combinators out of the box. You want to distinguish between those.
What's built in should be the focus.
And even to answer, like on top of built in, this is like the answer to a conversation I had once with a bunch of C++ folks, a few of who were sort of functional programmers. And it was like, what makes a language functional? Like, honestly, this whole podcast is similar to what is a functional programming language? This is the equivalent. But you know, what is an array?
Must not get into, or we'll never get out.
And I wish more podcasts, like that's the thing, is LambdaCast. I think they had a kind of episode on it, but not really freeform discussion where, because that's the thing is at one point, you know, a couple of folks were saying, I disagree, but don't want to invalidate. I think when it comes to this, everyone is allowed to a certain extent their own opinions of what they think a functional language is or an array language is. I think it's just a super interesting discussion for what are the criterion that people expect. And for me personally, when I hear Bob talking about the way you think, I completely am in love with that idea of the array quote unquote languages, but have sort of realized that I also think other languages are array languages that don't do that, but still have a lot of the same properties that are a superset of the properties or a subset of the properties that I would look for in sort of the quote unquote Iversonian languages. And I think when it comes to languages like Dialog, APL, J, and BQN, it's very, very idiomatic to make use of the combinators because they're built in. Also in Haskell, you don't have a full set of combinators, but it's also very idiomatic to use, flip, which is the C combinator, and join, which is the W combinator. And there's something called app, or the applicative functor, which doubles as the S combinator. These things are super, super common to be used in Haskell, even though they don't come with the language. There's only one that comes with the language, which I believe is the B combinator, which is the dot operator. But I think it's less. Does it come as
Haskell? So all you have to do is write an import statement in your program, and you get it, right?
Correct. But
it comes with the language, but it's not.
It's in a library, but I think it's less important whether it's in the language versus in the library. The question is, what is considered idiomatic use? Is the average, Haskell or BQN or APL programmer? Because that's the thing is when I was having this conversation with the C++ devs talking about, what is functional programming, that's what someone's response is like. Technically, where does Swift fall, or where do languages like F# that are both object oriented and functional? And even for that matter, Haskell, it's a pure functional language, but there are corners of the language where you can do a bunch of unsafe stuff and start writing code like C. And his response was that because the majority of Haskell programmers program in a very sort of pure functional way, it's considered a pure functional language. But if the norm was for everyone to be doing like C low-level stuff and pointer mapping and whatnot, it wouldn't have the same reputation. Anyways, that's one take. Whether it's correct or not is a different conversation. I'll stop talking though for a sec. Do people have comments about anything that I've said in the last couple of minutes?
It sounds to me like what you're talking about though is the paradigms of the languages, right? There's an array programming paradigm. There's a Lisp type programming paradigm. There's object-oriented type paradigm. Whenever you're talking about paradigms, you're talking about ideas that might not be as strongly represented in the other languages, but the concepts could be there. It's just that that's not primarily what that paradigm, addresses or works with. And to me, it's interesting, like with combinators, you see them across different paradigms, that you get functional programming like Haskell, sort of in terms of combinators, similar to combinators used in APL or J or BQN. But it's almost like combinators are something that could be considered cross paradigm, but actually maybe they are a different paradigm as well, as opposed to, the lambda calculus, which is again a different paradigm for looking at operations that way.
Yeah. And I think it's a great point. And in many languages, like in C++, you could implement a combinator library, but that's not going to make it a combinator language because there's millions and millions of C++ developers all doing different things. And it's.
So I want to protest them. You cannot say that, we just have to import it. Well, what if nobody wrote the library yet? So you have to say the ability to do this.
If you just install Haskell, you can't install Haskell and not include that combinator library. It's
so does Dialog APL include all of the defense workspace and all the other workspaces that come with various samples for things as part of the language?
I would say so. I mean, with the caveat that, yes, how people use the language matters for, describing what the language is really, because, the language is not just literally the binary you install, it's also what parts of it you use and things like that. But I also wouldn't say that defense changes APL from being, fundamentally in the array paradigm. So I'm not sure that's too consequential.
All right, we're at the hour and 20-minute mark here, and we got to start to wrap this up. So we will come back to this. This episode will be titled, actually, what is it going to be titled? We'll figure out the title offline. And there will be a second part 2 of this that we'll call Iversonian languages versus array languages. Maybe that'll be full stop, or maybe we'll do versus combinator languages versus functional. We'll get all the SEO optimization. But before we end, I think we should talk about very quickly Futhark and Q and K. So I think Q and K will be quicker. Where do people think Q and K belongs? I think it's outside the combinator languages circle. The question is it inside the Iversonian languages circle?
I definitely would say that inside Iversonian.
Well, I think it's actually more obviously an Iversonian language than it is an array language, because all these NumPy and R are definitely pretty focused on multidimensional arrays. Obviously, APLJ and so on are. And K and Q, along with Julia, are mainly focused on one-dimensional arrays, I think. Like Julia, if you just ask for an array, you're going to get a one-dimensional one, right? Like that's default. So I might even say that, Q and K are Iversonian, which is the category that I've been calling array languages. But they don't fit into this other category, depending on how strict you are about the boundaries. Certainly you can program as though you're using multidimensional arrays. You can think of them as multidimensional arrays, but they don't work in quite the same way as APL and J arrays.
No, they don't work the same way, but you can program in them that way. And I would also say that because, as Stephen originally started off saying, you can represent vectors, then in that sense, as long as you're not just working with scalars, I think technically you're probably within the bounds of array languages.
Yeah, I would say also, I think that you're within the bounds. It's just that there's a much stronger case for putting them outside the bounds than
for the higher
languages.
Dimensions. Yeah.
The thing you can't do, but you also couldn't do this in APL 360, is that you can't have like a multidimensional array of strings, because that axis that you get from making things into strings gets combined, so you'll just add a dimension instead. So from the perspective of a multidimensional language, that's kind of weird.
Obviously, a programming language needs some kind of sequential storage, right? Every programming language pretty much has arrays of some sort or lists of some sort to store data, but many languages don't really have any facilities to directly work on arrays. Some don't even have some, right? You have to loop over and add up. So having arrays is definitely not an indicator of being an array language. Every language has arrays of some sort.
Yeah.
Question is, so a lot of languages have some facilities for dealing with arrays, if nothing else, reversal or summing or things like that. If you take away all of those abilities, those languages will largely remain functional in the sense that you can still use them. You have to write something differently, but you could still use them. If you take away the ability of a language to deal with arrays directly, and that causes the language entirely to fall apart, like you can't do anything anymore, then I would say it's a proper array language, possibly Iversonian type thing. And I would say that's the case for all of these APL type languages and Q and K. Right? If I remove the ability to operate on entire arrays, in Q. Okay, you can't do anything anymore.
I mean, assuming you also remove dicts.
Yeah,
or
well,
maps or whatever you want to call them.
You can't.
I mean, yeah, you could have a version of K that used only maps.
Should we quickly hear from our resident KQ expert, Stephen? Do you want to agree with or not agree with the fact that Q and K are being placed in the Iversonian languages?
Yeah, absolutely. Solid core Iversonian.
All right. And very quickly then, we'll two last. So, I mean, or should we kick this to, because I feel like we're definitely at the hour and a half mark. Maybe we'll kick the discussion of Futhark and where it lives here to another episode. And then, yes.
I mean, I don't have much to say.
All right. If you want, we'll do 60 seconds from Marshall Lockbaum on thoughts on Futhark and does it live outside of this? I've for folks that are watching this on YouTube, you'll see that it's living outside all the circles right now. But go ahead, Marshall.
Yeah. So the Futhark does call itself an array language. But what I see from reading is this is much more about how it's implemented than what the programmer is exposed to. But it's interesting because these levels like have a lot of interface between each other. So on the programmer side, Futhark looks like kind of a restricted ML family language. It's a lot like Haskell or OCaml or all the other stuff in the ML family. But in order to make sure it runs on GPUs, you have a lot of restrictions on like what your types can be. And it has to, a lot of things have to be possible to be resolved when it compiles. So when you're programming, you end up thinking about, how are all my arrays laid out? I mean, you have to say, what type is this? And the type has to fit into an array model, basically. So in one sense, it's just like a sort of like Haskell that's been cut down to fit into an array model. And in another, it's like array programming that you express through Haskell. So I don't know quite what to make of that.
Yeah. I didn't even really get to talk about my second Eureka point. The first one was the delineation, and we're going to do a hard stop in a couple minutes here because we've definitely gone over. But like I said, we'll promise part 2 of this, which we'll call something similar. And the preview of the second Eureka point is that Stephen mentioned implicit iteration. We've talked about rank polymorphism and just not having to be explicit about your indices. And I realized that rank polymorphism, I have semantically attached to the rank polymorphism model inside of JBQN and Dialog APL. But I think really rank polymorphism is just an umbrella term for any way to deal with rank polymorphically. It doesn't necessarily need to be, and the secondary thought to that is that, a lot of these are leading access rank polymorphism. So you could acronymize that to LARP, but there's also trailing access rank polymorphism. And then there's also the rank polymorphism of Julia and NumPy, where the default of your operations is just to reduce everything to a single number. So when you sum a matrix, you just get back a single number. Whereas, and I don't know what you call that. I've in my head been calling it axis agnostic, but it's really only axis agnostic by default. And then, I think I said something in a past episode where I said, that the reverse function of NumPy flip doesn't even work correctly. That was wrong. It actually just calls the two different. I was using axis equal to 1 and 2. Axis equal to 0 is, so axis equal to none is the default. That sums everything into a matrix. So that would be the equivalent of raveling something and then summing it up in our
into a matrix
languages.
Or into a scalar. What do you think?
Into a scalar. So if you sum up a matrix in NumPy and Julia, the default is that it gives you back a single scalar, rank 0 number, rank 0 array, which is the equivalent of raveling or raising something in our languages and then summing it up. And if you then do axis equals 0, you get column-wise summation. And I think I switched. I was going from reversing to summing, but reversing will reverse column-wise, and summing will sum column-wise with axis equal to 0. And then axis equal to 1 is the row-wise one. And I think in a past episode, I said I tried to do axis equal to 2 and it doesn't work. And they just have a hard-coded, flip UD for up, down. So even though that is a hard-coded thing, they do actually have the general concept of rank. It's just backwards. Anyways, I'm going to stop talking. We'll talk more about the fact that I think rank polymorphism is this umbrella term. And if you have any facility in your language for dealing with rank such that basically you don't have to explicitly map, which is what Futhark does, and which is why I have sort of Futhark outside of the array language, is that I was very surprised that when I got to Futhark, I had, in order to sum up the basically lists of your lists, because they represent their matrices as just like lists of lists, you end up having to map like you do in Haskell or any sort of functional language. Any last final thoughts before we wrap this up, which we're close to this being our longest episode after I said we were going to keep these short, but then I got carried away with my Venn diagram. It's all my fault.
And I'm not sure what we say to those people who might only be listening to this on their podcast during their walk or something, because that's how I'm going to listen to it. If you get a chance, I mean, the diagrams and everything are fairly, they show things fairly well. But I don't think, having watched people create the diagrams, there's any way that you would be able to follow it on audio. There will be, we'll put a link up for the YouTube of the actual video of the diagrams being created. And honestly, that's fairly entertaining as well. So
even if you can't watch the video, we can certainly can save this.
Yes,
we can link to that, just that image. Like say,
well,
if your bandwidth can't handle that.
I'm about to tweet this out in like 3 seconds.
Okay,
to the tweet.
And I plan on creating a polished version of this, and definitely look forward to the part 2 of this, because we haven't really even talked of all the languages, single assignment C, and there were some topics I was hoping to get to, like, representing Booleans as ones and zeros and small things like that, because, there's a bunch of things that I think we could still continue to talk about in this sort of domain.
I just think we should all be listed as collaborators on your dissertation when it gets published.
If it ever gets published, yes. And no, I'm not doing a PhD currently. That was a joke from Bob. But if I ever do,
it'll probably be on this.
Yeah. All right. Any last thoughts, comments? I guess I said that a second ago. Folks can contact us at ArrayCast. Contact at
ArrayCast.com. Show notes will be in, and there will be a YouTube up that people can take a look at and follow this along, or as Dan pointed out, we'll put a link up to the actual still graphic as it is now, probably, because it's sort of complete and is interesting.
Well, I'd say it's probably complete with some definition, but I'm sure if once I post this, people are going to say, how come you didn't include language X? And sure, that'll be good for people commenting and whatnot. But I think it'll be interesting as a reference going forward too, because hopefully we can get some folks to talk about languages that aren't really represented, like Nial, and even languages that are array languages but outside of Iversonian, because I think definitely we've been focusing on the Iversonian languages rather than sort of the broader picture of array languages. So it'd be cool to talk to folks, on Julia and NumPy and R and stuff like that.
So I'd like to just mention that API Wiki has a couple of family tree of array languages, which is not really family as much as showing that there's some influence going from here to there. That might be, if you like this kind of content, you might like that.
Yeah. And while we're mentioning links, Marshall himself actually also has I think we've mentioned this before on the podcast, before you were a regular panelist, I think it's the functional programming post, but it has very similar to this Venn diagram of functional languages and array languages and sort of how BQN fits into that Venn diagram. But it also mentions a ton of other ones, it's a super interesting read if you like this kind of programming paradigm kind of stuff. All right. With that, we will say happy array programming.
Happy array
programming.
So hopefully, if you made it to the end of the video, you enjoyed. If you've got questions or comments, feel free to leave them down in the comment section down below. As mentioned at the top of the episode, a link to the website for the podcast and all the show notes along with that podcast episode can be found in the description down below. as well as you can just find this podcast on any sort of popular podcast app, Google Podcasts, Spotify, Apple, etc. On top of ArrayCast and sort of this behind the scenes video, tomorrow, which will be Saturday 17th, if you are watching this before that time, at 1 p.m. Eastern Standard Time, I'll be premiering a APL talk that I gave once in Toronto and once in New York at 2 different meetups that is going to include this graphic and talk about sort of comparing APL versus BQM versus J, as well as comparing them against other languages like R, NumPy, Julia. And I think there'll also be a Q example in there as well. So link for that will be in the description as soon as that video is up. And yeah, hopefully you enjoyed, and we'll see you in the next video.